Let us now look at the properties or characteristics of standing waves. Whatever is given here is just a recap of the earlier learned topics. Property 1 says two particles or any two particles in consecutive loops differ in phase by pi. That is, if we look at a case where we are standing wave like this, now these are called as loops. The points here where the particles have zero displacement are called as nodes. That is, the red color ones are called as nodes, and the black one are called as antinodes. Now what is seen here is, in one loop, if all the particles are traveling towards the mean position, that is traveling downwards, then particles in the next loop will move in upward direction. So as seen here, the particles in two different loops, that is, all the particles in a given loop will have same direction of velocity. Their velocity is different, but they have same direction of velocity. Similarly, the particles in this loop, all these particles have same direction of velocity, but they'll have different speeds. Now in this case, as seen here, since the particles in this loop are coming downwards and the particles here are going upwards, any two particle, a particle from here and from here, these two particles will differ in phase by pi. That's the first property. The second property is already learnt. The distance between a node and its immediate or next antinode is lambda by 4. We have already studied this. Next property is two consecutive nodes are separated by a distance of lambda by 2, which also is learnt. Two consecutive antinodes are separated by distance of lambda by 2, even that also studied. Next property is all particles on the stationary wave are in a state of vibration except those at the nodes. Even this is studied. That is, we know that in case of standing waves, all the particles are vibrating, but those particles at the nodes will not vibrate. Next property is stationary waves do not transfer energy, because by definition these are waves which are confined in a given region. Since they do not leave this region, these waves will not transfer energy. The energy is confined in this region only. That's the meaning of the statement. And then next statement is amplitude increases as we pass from a node towards an antinode and decreases as we pass from an antinode towards a node. That is, let us take a case like this where we have a standing wave. Now we know that the particles at the node will have no vibration. When we move away from the node towards the antinode, then the particles will have a different amplitude. The particles here at the antinodes will have the highest amplitude. So the particle somewhere next to it will have a lesser amplitude. This particle still less amplitude and less amplitude. So when you go from the node towards antinode, the amplitude of each particle is increasing, and when you move from antinode towards a node, even then the amplitude will decrease. So the amplitude is maximum at the antinode and decreases on either side of the antinode. That is what is given here. Next property is within the loop, all the particles pass through their mean position simultaneously in same direction with their own maximum velocity, which means all the particles in a given loop, that is all these particles will cross the mean position at the same time. So even though these particles at different speeds, they will all cross the mean position simultaneously. Similarly, particles from here will also cross the mean position simultaneously. But if you look at a particle somewhere here, we'll call as particle 1, and a particle 2, and a particle 3. If we look at 3 particles, the particle 3 will have a higher distance to cover before reaching the mean position. So particle 3 should have a greater speed. Particle 2 covers less distance, will have lesser speed, which means each particle will cross the mean position simultaneously, but each particle will have its own maximum velocity. So these are some of the basic properties of stationary waves.